The views expressed in this program do not necessarily reflect those of this station.
Welcome to Insights into Northeast Michigan, a WBKB News public affairs program. Insights deals with the issues affecting those in the community as well as Northeast Michigan and the state. And now, Insights into Northeast Michigan.
Hello and welcome to another Insights. I'm Lauren Mixon, and today I am here with Andrea Mills, and she is the Communications Associate for the Great Lakes Fishery Commission. And I'm also here with Tyler Buchinger, and he is a postdoc researcher at Michigan State University. Welcome, guys.
Thank you.
Well, thank you so much for allowing us to come out today. Right now we are sitting on the shore of Lake Huron at Hammond Bay Biological Center. So if you guys could tell me what you do here.
Yeah, we'd be happy to. So both Tyler and I are here right now at Hammond Bay Biological Station, where we do research on Great Lakes fisheries. Now, our station is best known in northeastern Michigan because of the work that we do on sea lamprey, but we also do research on other fish species such as lake trout, which will be what we'll be talking about today. And Tyler is one of our star researchers here. He's a visiting scientist that comes up for a few months each year to study lake trout. But more generally, Hammond Bay Biological Station, it really exists to help the native fish populations in the Great Lakes. One of the ways we do that is by controlling sea lamprey, but ultimately we are interested in having healthy fish populations throughout the Great Lakes. Those fish populations are very valuable to the Great Lakes region. Currently, our fisheries are valued at over $7 billion each year. Historically, those populations were also quite valuable. They were valued at least as much as $7 billion in current day numbers, current dollars. They potentially were valued even more than that historically, as in over 100 years ago. One of the species that made up much of the value of commercial fisheries and other fisheries historically is lake trout. Lake trout are one of our native fish in the Great Lakes. They grow to be quite large. Some types of lake trout can grow to be even over 100 pounds. They're a fairly tasty fish, especially when smoked. And so people have harvested them for well over a century in the Great Lakes.
Now, those have been impacted by sea lamprey, which we've talked about before on our Insights program. And we know that sea lamprey are an invasive species that have come into the Great Lakes, and they've impacted not only the lake trout, but a number of other fish. Talk to me a little bit about that.
Yeah, so when sea lamprey invaded in the late 1800s and early 1900s, they had devastating effects on fish populations throughout the Great Lakes. Sea lamprey are a species that tends to live deeper in the water. Other fish which also live deeper in the water, such as lake trout, were the ones that were most affected. But it wasn't just lake trout. Their effects extended to whitefish, burbot, sturgeon, walleye, even smaller fish like yellow perch. But because lake trout are a very large-bodied fish, they also have very thin scales. It was quite easy for a sea lamprey to get its rasping mouth and its tongue, which has teeth on it, and it licks or lashes a hole through the side of the fish. Those thin scales and the fact that the lake trout live in the bottom of the Great Lakes, where the sea lamprey live as well, that made lake trout really the preferred prey of sea lamprey. And sea lamprey were devastating to lake trout populations. The combination of overfishing of lake trout by humans along with sea lamprey attacking them led to the decline of lake trout in 4 out of the 5 Great Lakes. In fact, I shouldn't even say just decline. It was the complete disappearance of lake trout from 4 out of the 5 Great Lakes. The only lake where lake trout survived was Lake Superior, because that was the last lake that sea lamprey had invaded, and it was the first lake where the Great Lakes Fishery Commission and its partners began controlling sea lamprey. So flash forward a bit to the 1950s and 60s, sea lamprey were eventually brought under control. It's one of the greatest success stories in the Great Lakes, but unfortunately some of the fish like lake trout that were so devastated by sea lamprey didn't begin to repopulate the Great Lakes on their own. It took the work of scientists and fishery managers to begin reestablishing lake trout populations for their populations to eventually begin to grow.
Now, we know the Great Lakes is known for fishing and the water supply that we have here. And we're going to talk a lot about the lake trout today. But why is that so important? Why are the lake trout so important to be in the Great Lakes where they belong?
Yeah, there's reasons both economically and ecologically. I've hit primarily on the economics. They are a valuable fish 4 fisheries. Historically, those fisheries were largely commercial fisheries. Nowadays, our fishery for lake trout is primarily recreational, but there is some tribal fishing as well for lake trout. So they have that importance, but there's also a very strong ecological importance of lake trout to the Great Lakes, and Tyler is the best person to speak to that.
Yeah, I don't know about the best, but maybe here.
A great person.
A good person. Yeah, so lake trout have a really important role in the Great Lakes ecosystem. First of all, they're a top predator, so they sit at the very top of the food chain and feed on everything below it. One thing that's really interesting, before we had sea lamprey, we not only had many lake trout, but there were many different kinds of lake trout, where we had some that fed on whitefish, others that would feed on insects, and they, by feeding on these different food types, they lived in different places, and they looked very different. So when we lost all of the lake trout from sea lamprey and overfishing, we not only lost the numbers, but now today we only have a couple of kinds of lake trout. We don't have the diversity in lake trout that we used to have. And having that diversity kind of playing a critical role at different points in the food web is really important for the sustainability of the Great Lakes food web.
Now let's put this into perspective here. We're here and we do our own thing. Obviously, we're on land, the fish are in water, so we don't think about what's happening in the Great Lakes if we're just going about our normal day. But how is this all impacting humans?
Well, so the primary way that the decline of lake trout affected humans was through the economies. Because the fishing industry has historically been one of the largest industries in the Great Lakes region, the collapse of that fishing industry with the wiping out of lake trout and the reduction of other fish species from sea lamprey, it really caused the economy to crumble in the Great Lakes, across the entire Great Lakes in the 1950s and after. And so being able to have thriving fish populations in the Great Lakes is important because that really does support the economy. And you know, many of us even just, it's a part of our culture too to fish the Great Lakes. I grew up fishing on Lake Michigan near Chicago, and now where I live here, we take our son out fishing as well on the Great Lakes, and perhaps the same
me
for
as
you.
well, yeah. Yep.
Right, so it's a part of our economy and it's a part of our culture in the Great Lakes region to have healthy fisheries and healthy fish populations.
So we have quite a bit more to talk about, but we are here to discuss some of Tyler's research and how we're going to replace those lake trout. So if you could tell me just a little bit about what we're going to be seeing as far as your research goes.
Sure. Well, it kind of starts at the point where sea lamprey wiped out lake trout populations. And like Andrea said, we eventually controlled sea lamprey, but lake trout populations didn't rebound after we got rid of sea lamprey. So since then, there's been a large effort to put lake trout back into the Great Lakes with the hopes that they would become restored and maintain their own populations. But despite years of stocking lake trout, in most areas there's not very much natural reproduction. So where my research really starts is trying to figure out what might be missing to lake trout spawning and how we might be able to help them get to the point where they can maintain their own populations.
Well, thank you so much, Andrea and Tyler. We're going to take a look at some more of the research that Tyler is doing. And it's going to be a little bit more hands-on, so stay tuned for more insights. Welcome back to Insights. Today we are at Hammond Bay Biological Station, and we are talking about lake trout in the Great Lakes. Thanks for being here with us again, guys. So in our last segment, we talked a little bit about how the lake trout population has pretty much declined, and we're not seeing those in our Great Lakes anymore. And we know they've been attacked by sea lamprey, an invasive species in the Great Lakes. And they really haven't rebounded much since then. So let's talk about what we're doing to fix that problem, and that is helping some of those fish to reproduce. So let's talk about that.
Yeah. So yeah, one of the major questions that came up after lake trout didn't rebound on their own, and after we started stocking them, was how do lake trout reproduce, and where what's the problem that's keeping them from maintaining their own self-sustaining populations. So there's been quite a bit of research looking into what the process is of lake trout spawning, and I'm involved with that, and also some other people here at the station are. And the picture that's kind of come together of how lake trout spawn is it kind of all starts in the fall, usually in early October when the lake temperatures start to drop, and there gets to be less hours of light during the day. Those two cues are really important. Male lake trout come up onto spawning reefs that are pretty close to shore. Like in Thunder Bay, there's some important spawning reefs. And the males come up, and they'll, especially at night, they come up on these reefs and they do some different behaviors interacting with other males and trying to potentially establish who's going to have access to females. And then eventually, in mid to later October, the females will come as well. And they'll basically how the spawning act, the process is females kind of swim around and are followed by maybe 3 or 4 males. And it's really interesting because the whole group will be swimming together, and then all of a sudden the female will decide it's time to release her eggs, and the whole group will sink down to the bottom of the lake, right up against the rocks, and spawn all at the same time.
So you mentioned the term spawning reef. Tell us a little bit more about what that is.
Yeah, so a spawning reef is, we're finding that there's a lot of variation in what a spawning reef could be. So what I'm referring to is basically large piles of rock that are out in the lake. There was some recent work done from here to Hammond Bay that found up in Drummond Island, there's these large boulders that lake trout spawn on. So just by looking at what they're doing, we're finding that what we always thought was how lake trout spawning is much more different than, it's not consistent. Different fish certainly spawn in different ways and in different habitats. So it's really raising these questions of how lake trout decide and find where to spawn, and then also how they find other fish to spawn with.
So you're doing some of that research right here at Hammond Bay. Talk to me a little bit about what type of research you're doing and how that's going to help repopulate the Great Lakes.
Sure, yeah, so there's a couple different things we've been looking into, and one I think really interesting study that isn't a huge part of what I do was with some others here, we found that lake trout are actually making sounds when they're on the reef. Which typically you would associate that with birds singing,
right.
or other animals certainly make a lot of noises, and you don't think about fish making noises. But actually, many fish do make calls, I guess you could say, during spawning and during other behaviors. So we found some evidence that they're actually making calls out when they're spawning. But most of the research that I do is actually focused on their sense of smell. So there's a couple different ways that we think lake trout might use their sense of smell during reproduction. The first one is kind of comes from a lot of work with Pacific salmon, where they, when they're leaving the stream that they're born in, they learn the smell of that stream. It has a characteristic odor. And then a couple of years later, as adults, they come back to that spot following that smell. And we know a lot of fish do that, and we thought maybe lake trout would be one of them. And so that's one type of way they would use their sense of smell. The second one that I'm more focused on is the use of pheromones, just other compounds that are released by other lake trout that they can use to both find mates and interact with them. So a lot of my research is focused on trying to figure out how lake trout might use pheromones to find mates, and then also trying to specifically identify what those compounds might be.
So we're going to see in a later segment exactly what he's talking about when he's referencing the research that's going to help repopulate the Great Lakes. But you talk a lot about pheromones and that sense of smell. Mm-hmm. So when you're narrowing that down, how might those sense of smell, the smell that they're experiencing, help them reproduce?
Yeah, so we know in a lot of fish that their sense of smell is actually critical when they're spawning. So they use it to both decide or figure out if it's a male or female, because sometimes, like I said, lake trout are spawning at night, and they may not be able to see each other as well as we can when we're up here during the day and out of the water. So they use their smell just to figure out who it is that they're interacting with, and then often fish release a different odor when they become ready to spawn, so they can indicate whether that is a fish that's ready to spawn with. And actually the pheromone that I've found is probably the most important is one that males release, and actually attracts females and other males. And what we think it might do is help them aggregate on those spawning reefs during the spawning season, and be in a spot where there's likely other fish that they can mate with. So a lot of the work I'm doing now is trying to identify what that male pheromone is. And actually how we start that process is I have to collect a lot of it. And through some different behavior experiments I've done, I actually found that the smell is released through the male's urine. So what we do is we put a catheter into a male, actually. It's pretty interesting. And we collect as much male urine as we can.
Wow, okay.
And then I work really closely with some chemists down at Michigan State who can then take all of that urine that I've collected and do chemical experiments on it to try to figure out what the compounds are that are in there. And then I take that information back up here, and in the experiments that I've set up here, we can test to see if those compounds that were identified in the urine replicate the behaviors that we saw to the male odor.
And now, speaking of collecting, this takes a little bit of work because you have to go out and you have to collect the fish that you're going to use in the experiment. Tell me a little bit about that process.
Yeah, so I'm right now, like I said, I was from Alpena, but I live in East Lansing most of the year. But then during the lake trout spawning season, I come up here for a couple of months to do the work. Usually early October, and it all starts with collecting the fish. We use just hook and line to collect our fish because it seems to be the least stressful on them, collecting them from the wild. And that usually takes several days. It involves getting a collector's permit and everything like that. And then we bring them back here, and I go through and see who we caught, and I put tags in them to keep track of all the individuals. And then we do all of our experiments at night because lake trout spawn at night. So it takes a lot of time, and not necessarily the time that we would usually be active, but we kind of go by the lake trout schedule.
Absolutely. So let's talk about how this research is going to be used in the wild and in real life to help repopulate that lake trout species. So when you finish collecting this research and you've kind of understood the processes that they go through, how is that going to help the population rebound?
Yeah. So like I said, one of the questions that we've had is how lake trout are finding these areas to spawn. And there's actually been efforts to restore spawning reefs that used to be good and are no longer good. And we can do work to make those good spawning reefs again, but we're not sure if lake trout will use them. So if we can figure out smells that they're attracted to, we could potentially apply those to those reefs and get lake trout to come back and potentially start spawning in those good spots that aren't being used right now.
Any projections on how that will work out in the wild, or how long it'll take to start seeing a change?
It's hard to say. It's quite a long process to identify the compounds. So we started this research in 2012. So it's been a couple of years already, and we still need a couple of years. And then obviously working in the lab here at Hammond Bay is really useful for controlling some things, but the environment out in the lake is much different. So we certainly have a lot of research that we need to do still.
Well, I'm definitely excited to see how this all works out. And we may not be able to see that in the wild, but we will see how that's working a little bit here at Hammond Bay and the research that Tyler is doing. So don't go anywhere. We'll have more insights when we come back. Welcome back to Insights. I am here with Tyler Buchinger, a postdoc researcher for Michigan State University, and he's going to be showing us a little bit about what he's doing with the lake trout. So what are we going to be looking at here, Tyler?
Yeah, so most of the research I'm doing in here is studying lake trout's sense of smell. So we're interested in developing tools to use compounds that they're attracted to aid in restoration in the Great Lakes.
Perfect. You ready to walk over and take a look?
Sure, yeah. So first we'll head over here. I need to turn the water on to fill the raceways for my experiments. And all this water is coming right in from Lake Huron. It's pumped in to a large water tower, and then that water tower pumps it through here. Right now, I have the fish in those green tanks in the back, and this will fill these raceways, and then I'll put the fish into the raceways so that we can start our experiments.
Cool.
Yep. And it takes a moment to fill up, but you can see over here the water is starting to move in.
And this water just comes right in from the lake to simulate the actual environment.
Yep. So this is really a pretty unique spot where I can do these experiments because we have access to Lake Huron water that we can pump through these raceways at a high enough volume that I can have the fish act like they're in the lake where they would naturally be.
Now, is there a certain amount of times that you'll need to do this in order to get accurate research amounts?
Yeah, so I actually do most of this work at night because lake trout spawn at night out in the wild. So usually we would have the lights off, and right about sunset I start the experiments. And then one experiment takes about 2 hours, during which I pump these different smells, and I watch the lake trout and see where they're moving to.
That is super interesting.
Yep. And I start these, I kind of follow the natural cycle of lake trout out in the wild, where we start these experiments in early October, and then pretty much go until it gets too cold for the fish to want to do anything anymore, usually in early December.
What about temperature? Do these have to be set at a certain temperature, or is it just, it comes right in from Lake Huron and it's already the right
So yeah, this comes right in at the ambient temperature of Lake Huron. We do have some tanks in the station here that we can control the water temperature, but for the volume of water that's moving through here, it'd be really difficult to control the temperature. And actually, for lake trout spawning, the water temperature needs to be at what it is in the lake anyway.
Right.
So it's really perfect for my experiments just to use the natural water temperature.
Now, did those fish, the ones that are going to be in here today, are those right out of the Great Lakes?
Yes, yeah, yep.
So this will be then a perfect simulation for the most part.
Exactly, yeah, yep. We can put together a scenario that very closely matches what they experience in the wild. These are all actually males that we caught out on a spawning reef.
What's the process like for catching these fish and gathering them for this type of experiment?
Yeah, so we actually are forced to collect these hook and line, which isn't the worst thing you can do for a day at work. So we've found that the least stressful way for us to collect them for these experiments is just to fish for them. So we go out on the boat. It's sometimes kind of nasty weather. The falls here can be a little unpredictable. But yeah, we just go out and fish for them, and then we have a large tank on the boat that we put them in and then bring them here, and I sort through them before using them in experiments.
And this is pretty time consuming, I can imagine.
Yeah. So they've gone fishing, I think 3 or 4 days. Well, they'll spend the whole day out there fishing. And we get the season isn't open right now, so we get a special scientific collector's permit to collect them. And then, yeah, it takes a lot of time to collect them, and then going through them, I sort to see if they're male or female. And then you can see they have little colored tags on their fins.
I see that.
So I go through and I put 2 of those on each fish, just so that I can keep track of who they are. And I kind of assign them a number and a unique color code. So I know all the fish that I have.
So how many fish usually go into the raceways during experiments?
I usually just do 1 at a time. That way I eliminate any interactions they would have with other fish that might confound my results. So each night we put 1 fish in each side, and then after it's acclimated for about a half hour, then we have infrared cameras that you can see up above the raceway that we use to record where they move throughout the raceway. And you can see behind that black tarp over there, we have a computer set up where we can watch the video from the cameras. And we have it set up behind that tarp because, like I said, they don't like light, so even that light from the screen might affect their behavior.
So let's talk about the pheromones that you're using to try to repopulate the Great Lakes, because that's a big portion of the research here.
Yeah.
So how do you go about simulating certain pheromones, and where do you place them, and what does that mean?
Yeah, exactly, yep. So I guess to the process of doing that, I can show you. What I use are these peristaltic pumps to do that. You can see there's really long tubes that they kind of go all the way back to those tanks. So I put one of those in the tank that I want to apply the odor of, and then it comes here. I turn it on. You can see that that odor from the tank comes in here, and we calibrate it so that it's coming in at a specified rate per minute. And then after the fish has had that half hour to just get used to the raceway, we start pumping, And then what I do is I pump one smell into one side, and then either nothing or a different smell into the other side. And then we can record how much time the fish spends on each side. And what I saw before is that they spent a lot of time if the odor of another male was there.
So let's talk about how this helps us with what we're really talking about here, and that's repopulating the Great Lakes with these fish. How is this helping us learn about that process?
Yeah, so there's a couple different aspects of it. I guess most broadly, we just don't know how lake trout spawn and what factors really influence whether they are spawning successful. And based on other fish, we know that sense of smell is really important for that. So kind of at the most basic of, we're just trying to figure out how they use their sense of smell when they're spawning. I guess more specifically, if we can identify what those smells are, we might be able to apply them to spawning reefs to get lake trout to use. So for years we've been stocking lake trout, and in many areas they don't reproduce naturally. And one of the ideas of why that's the case is they might not be using spawning reefs that would be good spawning reefs for them to use. So if we can use smells to bring them back to areas that are productive spawning reefs, we might be able to encourage natural reproduction.
Well, thank you so much, Tyler, for showing us around and showing us a way that we can potentially repopulate the Great Lakes with some of these lake trouts. And that was another Insights. Thanks for watching.
Insights into Northeast Michigan is produced by WBKB News. If you have any comments, suggestions, or topics you would like to see on a future show, please email WBKB News. This has been a production of Thunder Bay Broadcasting Corporation. All rights reserved.